well, something created the universe, or the universe is, here. How did it come to be? You could say whatever caused the universe to come to be is...
The billionaire behind groundbreaking tech dreams of propelling humanity into the cosmos, so why isn't he fully embracing the recent findings from the James Webb Telescope? We've been treated to stunning glimpses of the universe's origins as the Webb gazes into the abyss. This extraordinary machine has earned a reputation for unveiling cosmic wonders in unprecedented detail, yet it's a startling new revelation that has roused Elon Musk from his slumber. Speculation abounds that Musk's reaction to this discovery could hold the key to unlocking its mysteries. But what exactly is the connection, and what significance does it carry? Let's embark on a journey to unravel the enigma surrounding his response to the Webb Telescope's latest breakthrough. Musk's response to the discovery. Musk's reaction to the latest images captured by the James Webb Telescope. When we reflect on history and the influence of pop culture, it's evident that humanity has long harbored a fascination with space travel. However, it's only in recent times that we've begun to grasp the immense scale of the cosmos. The arrival of the Webb Telescope was eagerly anticipated as a significant upgrade to the Hubble, and it has indeed revolutionized the field of astronomy. Scientists held high hopes for the groundbreaking discoveries it would bring to light. Yet, its latest findings have surpassed even the loftiest expectations. Elon Musk marvels at the remarkable revelations unveiled by the Webb, providing us with an unparalleled vista of the cosmos. But what impact will this newfound knowledge have on our society? Despite being one of the wealthiest individuals globally, Elon Musk's interests diverge from the ostentatious displays of wealth often associated with extreme affluence. While others might flaunt luxury yachts or private jets, Musk's passions lie in more unconventional realms. His visionary pursuits extend far beyond the boundaries of Earth, making his fascination with the images of the vast expanse beyond our known galaxies entirely fitting. These images serve as poignant reminders of the immense and awe-inspiring nature of our universe. On July 13th, Musk took to Twitter to express his excitement over this significant breakthrough, highlighting his profound fascination with the potential offered by NASA's Webb Telescope. As a leading figure in the aerospace industry and a staunch advocate for interplanetary exploration, Musk recognized this event as a pivotal milestone in humanity's ongoing quest to explore the cosmos, and rightly so. Finally, we have a telescope capable of capturing more than 7 times the amount of interstellar light compared to its predecessor, the Hubble Space Telescope. One significant disparity between the two instruments lies in the Webb's array of advanced cameras and specialized instruments uniquely equipped to detect even the faintest infrared light and heat radiation, setting it apart from the Hubble. This isn't meant to diminish the extraordinary achievements of the Hubble during its heyday. The Hubble Space Telescope stands as a testament to human ingenuity, granting us unparalleled glimpses into the vastness of the cosmos beyond our wildest imagination. However, after 3 decades of service, its reign as Earth's premier telescope has inevitably drawn to a close. As the universe continues its expansion, light once visible to the Hubble has begun to fade from its reach. It was time for humanity to embrace a more advanced telescope capable of unraveling the mysteries of the cosmos, and thus emerged the James Webb Space Telescope. Since kicking off its scientific mission earlier this summer, the James Webb Space Telescope has brought fresh insights into some of the most astounding discoveries in space exploration. Most recently, the Webb team turned its gaze towards Titan's hazy atmosphere, using its infrared vision to unveil what appears to be a methane sea, sand dunes, and clouds. With a hefty price tag of $10 billion, this observatory has also captured breathtakingly detailed and vividly colored images, including glimpses of the earliest galaxies formed less than 500 million years after the Big Bang and the bustling stellar nurseries within the Carina Nebula. Understanding the telescope's abilities. Neil deGrasse Tyson, director of the Hayden Planetarium in New York, emphasized the cautious management of expectations due to the mission's complexity. Speaking to Fox News Digital previously, he noted that the telescope exceeded expectations by adhering to its design specifications. Thus, upon analyzing these images, it becomes evident that we are embarking on a new era of astrophysics, unlocking previously inaccessible vistas of the universe. Crafted through a joint effort between NASA, the European Space Agency, and the Canadian Space Agency, the James Webb Space Telescope took to orbit in December 2021, following the footsteps of the Hubble telescope. Bill Nelson, NASA's administrator, has praised the telescope's remarkable ability to peer back over 13 billion light-years into the past. One of its key instruments, the near-infrared camera, NIRCam, allows scientists to delve into discoveries akin to some of the Hubble Space Telescope's most celebrated findings. Tyson highlighted the Hubble's unique capability to detect ultraviolet light, imperceptible to human eyes. Telescopes undergo meticulous calibration to observe the universe across a spectrum of light wavelengths. The renowned scientist underscored that the James Webb Space Telescope translates these hues to render images visible to human observers. Initially, the brain constructs an image using 3 distinct bands of light, which are then combined to generate a full-color representation using RGB coding on computers. This process can be applied to any trio of bands across the light spectrum, unveiling numerous infrared images of galaxies. Among the remarkable deep-field images, previously obscured by dust or clouds, are striking spiral galaxies teeming with myriad points of light. However, the pivotal inquiry arises. When scientists scrutinize galaxies from a cosmos less than 1 billion years old, are they peering into some of the oldest galaxies in existence? The light emanating from the most distant galaxies represents the earliest emissions from stars, traversing the universe for 13 billion years. It serves as a testament to the earliest stages of galactic evolution. He underscores the importance of distinguishing between the concepts of old and new when contemplating galaxies continuously emitting light for 13 billion years. Scientists marvel at every image relayed from the early universe by the Webb Telescope, noting its awe-inspiring nature. The telescope's design is intricately crafted to detect infrared light, highlighting a temporal gap during which Earth struggles to gather high-fidelity data from the nascent cosmos due to the influx of UV light during star and galaxy formation. As these light waves traverse expanding space since the inception of the universe, they gradually shift to longer wavelengths, eventually manifesting as infrared radiation by the time they reach us. The Webb Telescope has peered into galaxies formed over 13 billion years ago, offering a fresh perspective on our own solar system. Elon Musk perceives it as a gateway to a new era of astrophysics, providing us with high-resolution, top-tier data. These groundbreaking images herald the dawn of a new epoch in space exploration, presenting the universe with unparalleled clarity. Yet, beyond their aesthetic appeal, they offer a window into the universe's infancy, a subject of Musk's interest. These images unveil over 1,000 galaxies, with one tracing back to the very moment of the Big Bang itself. NASA hails it as the most profound and crispest infrared image ever captured of the early universe. Remarkably, Webb achieved this feat in less than a day, marking its inaugural image release. Delving into the cosmos known as the Webb First Deep Field, the initial image features the galaxy cluster SMAC 0723, later inspected by President Joe Biden. This vibrant image showcases remote subjects such as the Southern Ring Nebula, Stephan's Quintet, and the Carina Nebula. NASA's social media platforms buzzed with excitement, with tweets like, "Geeking out yet," and "Our minds are blown," underscoring the profound impact of the image. The Webb Telescope currently orbits the Sun at a distance of approximately 1.6 million kilometers from Earth, stationed at what is referred to as the second Lagrange point. This cutting-edge observatory is the result of a collaborative endeavor between the space agencies of the United States, Europe, and Canada. With an estimated cost exceeding $10 billion, the construction and deployment of the Webb Telescope rank among the most financially substantial scientific initiatives ever undertaken, trailing only slightly behind monumental projects like the Large Hadron Collider at CERN. Elon Musk's reaction. The CEO of Tesla takes to Twitter. Engineered with a specific focus on capturing infrared light in the universe, a realm invisible to the naked eye, the Webb Telescope has swiftly demonstrated its value. In just 6 months of operation, it has ventured deep into the cosmos, unveiling light emitted over 13.5 billion years ago, providing unparalleled insights into the distant past of the universe. Shifting our attention to Elon Musk, his initial response lauded the telescope's vast potential. However, he appeared more reserved after witnessing its groundbreaking images. In an unexpected turn, just 2 days after the images were released, Musk posted a controversial photo of a kitchen slab with a pattern resembling cosmic formations on Twitter. Alongside the image was a sarcastic remark aimed at NASA. "Nice try." This tweet elicited varied reactions, with some interpreting it as a playful jest, while others viewed it as pointed criticism. One critic remarked, "Why not simply retweet instead of cropping? It's easier," confirming that Musk had indeed borrowed the witty comment from another Twitter user and opted to crop it rather than sharing the entire meme. Musk has garnered a reputation for being rather obstinate of late, even expressing his opinions on YouTube, labeling it a continuous stream of misleading ads, despite his ability to easily afford the YouTube Premium option. While Musk's stance on the Webb Telescope has transitioned from praising its vast potential to diminishing its significance, the awe-inspiring constellations it has captured remain undeniable. The images of SMAC 0723 showcased a sprawling galaxy cluster renowned among astronomers for its gravitational lensing effect. This intriguing phenomenon distorts and magnifies light within the cluster, creating the illusion of greater distance. Visually, it manifests as striking red arc-like formations, with light from these arcs traversing distances of up to 13 billion years to reach us. Next in line is the Carina Nebula, celebrated as one of the most expansive and radiant nebulae in our cosmic vicinity. Situated approximately 7,600 light-years away from Earth, it encompasses vast regions of dust and gas where stars are born. Affectionately dubbed the Cosmic Cliff by astronomers, its portrayal by the Webb Telescope is nothing short of captivating. Following this, the Southern Ring Nebula makes its appearance, serving as an inspiration for the avant-garde coffee tables currently being crafted by artisans across Europe. Essentially, the Southern Ring comprises an expanding shell of gas and dust, illuminated by the radiance of a dying star nestled at its core. Spanning an impressive distance, the Southern Ring boasts a diameter of nearly half a light-year and resides over 2,000 light-years away from our planet. Despite its classification as a planetary nebula, the Southern Ring Nebula has no association with planets. Its moniker stems from a historical misinterpretation during the early days of astronomy, when telescopic capabilities were less advanced. Additionally, Webb captured Stephan's Quintet, a cluster of galaxies nestled within the Pegasus constellation. Notably, Stephan's Quintet represents the first compact cluster of galaxies ever discovered, comprising 5 distinct members. Among them, one galaxy stands closer in the foreground, while the remaining 4 are situated approximately 300 million light-years away, engaged in a close cosmic interaction. What sets Stephan's Quintet apart is the intricate interplay among its 5 galaxies, as 4 of them engage in a dynamic cosmic dance. Utilizing Webb's remarkable infrared vision, scientists have delved into the unique characteristics of this galaxy cluster, a task nearly impossible with the Hubble telescope. Webb has also showcased its proficiency in detecting exoplanets situated far beyond Earth's atmosphere. Even seemingly mundane images from the telescope exhibit its impressive spectroscopic capabilities. Spectroscopy involves the dispersion of light into its constituent colors. the spectral data obtained from the atmosphere of WASP 96b, a colossal planet located approximately 1,150 light-years away, bears a striking resemblance to Jupiter, our neighboring planet in space, primarily composed of gas. Webb's advanced data collection on this planet enabled scientists to discern the various molecules present in its atmosphere. Unfortunately, WASP 96b is not conducive to sustaining life due to its proximity to its parent star, resulting in extreme temperatures within its hostile environment. Nevertheless, this underscores the pivotal role Webb is poised to play in the foreseeable future, potentially aiding in the identification of planets with environmental conditions akin to Earth's, and even uncovering signs of extraterrestrial life. Furthermore, there exists a possibility of Elon Musk collaborating closely with NASA to chart a clear trajectory for his Mars expeditions and potentially exploring other celestial bodies with the assistance of such a potent telescope now available to humanity. With ambitious plans for interplanetary exploration, there is a strong belief that Musk's newfound perspective on the Webb telescope should spur the evolution of new imagery. The advent of shocking new imagery prompts us to grapple with the concept of peering into the distant past when observing celestial bodies, considering that it may have taken millions or even billions of years for their light to reach us. Are these bodies still flourishing out there? Despite light traveling at an astounding speed of 299,792,458 meters per second, the vastness of the universe remains incomprehensible. The recent insights gleaned from the James Webb Telescope have the potential to fundamentally transform our understanding of the universe's origins. Musk likened it to the unique fingerprint of all chemical processes. Emphasizing the occurrences within celestial bodies, he underscored its significance in shedding light on both the chemical composition and its role within the cosmic expansion model. In light of recent disclosures from the White House regarding these phenomena, speculation surrounding unidentified flying objects, possibly of extraterrestrial origin, began to circulate. While the White House later reaffirmed the absence of evidence for aliens or extraterrestrial phenomena, no further clarification was provided. Furthermore, the James Webb Space Telescope has unveiled to astronomers a glimpse into the cosmic journey, leading to a remarkable discovery: the existence of massive distant galaxies defying conventional expectations. These immense structures caught astronomers off guard. Researchers are now grappling with the challenge of pinpointing galaxies nearly as colossal as our own Milky Way, brimming with mature red stars. In the deep field images captured during the James Webb Space Telescope's initial observational phase, these galaxies appear as minuscule reddish dots to the powerful telescope due to their extreme distance. These findings are outlined in a recent study based on the initial data release from Webb's observations. Astronomers made a groundbreaking revelation. They were observing these galaxies a mere 700 million years after the Big Bang. By scrutinizing the light emitted from them, ancient stars, the existence of such ancient galaxies isn't inherently surprising. During the universe's initial 400 million years, when only a dense fog of hydrogen atoms permeated space, astronomers anticipated the emergence of the first star clusters shortly after the universe emerged from the so-called Dark Ages. However, the stars captured in Webb's images appeared exceedingly ancient, and the galaxies themselves were unexpectedly massive. These recent discoveries mark a departure from earlier observations made by Webb's predecessor, the Hubble Space Telescope, challenging established theories regarding the appearance and evolution of the cosmos during its infancy. Joel Lacha, one of the authors of the study and an assistant professor of astronomy and astrophysics at Penn State, noted that they held certain expectations regarding the types of galaxies thriving in the early universe. It was anticipated that these galaxies would be young and relatively small. Hubble and other instruments often detected small, youthful blue galaxies in the early cosmos, emerging from the primordial cosmic milieu and in the process of forming stars and structures. Typically, The light emitted by young stars has a bluish tint, which gradually reddens as stars age and deplete their fuel. While Webb was designed to detect distant galaxies, astronomers were surprised to find ancient crimson stars within them. Similarly, they were astonished by the discovery of galaxies with masses exceeding 1 billion suns. Yet, the crimson specks observed in Webb's deep fields appear to be a remarkable 50 times more massive. Scientists observed that the largest galaxies they studied had masses 2 to 4 times smaller than the Milky Way. They identified galaxy candidates as large as our galaxy when the universe was just 3% of its current age. Before astronomers reconsider their hypotheses about the rapid formation of these galaxies after the Big Bang, they need to verify that the peculiar red spots they're observing are not something entirely different. However, it's important to note that most alternative explanations also necessitate new concepts. For instance, because stars in the early universe lacked many heavy elements, they might emit light in different ways not accounted for in current models. Alternatively, conventional mechanisms of star formation, such as the conversion of gas into stars based on a star's size, may have played a lesser role in the early universe. These discoveries also promise excitement, challenging our understanding of how stars formed in the early universe in a completely new light. As part of the Cosmic Evolution Early Release Science Project, Webb's near-infrared camera captured images of these enigmatic galaxies. Soon, astronomers will redirect Webb's mirror towards these galaxies to delve deeper into their light spectra, dividing light into its constituent colors, helping us gain insights into their origins and composition. Just a few months after the Webb team astonished the scientific community with the initial findings from the expansive observatory, scientists are already feeling compelled to rethink their comprehension of the early cosmos. The immense galaxies defy the expectations set by 99% of models of ancient galaxies in the universe, prompting researchers to reconsider their theories on galaxy formation and evolution. But that's not all from the James Webb Telescope. The more we uncover about Stephan's quintet of dark angels, the more we realize the complexity and turbulence within this corner of our universe. Further investigations with the James Webb Space Telescope and the powerful Atacama Large Millimeter Submillimeter Array, ALMA, have unveiled sheer chaos unfolding among these 5 luminous galaxies. Revealed at the annual American Astronomical Society news conference, the scene depicts intense upheaval among these galaxies. Notably, one galaxy, NGC 731b, dubbed the Intruder, is unleashing a colossal shockwave spanning multiple Milky Way galaxies as it intrudes upon the space between the other 4 galaxies. The spectacle is striking, with this immensely powerful wave igniting a hub of activity, triggering the recycling of warm and cold molecular hydrogen gas clouds amidst the quintet. While the occurrence of a molecular cloud piercing through intergalactic gas and causing chaos in its wake may be rare and not fully understood, the data indicates significant progress in comprehending the remarkable behavior and tumultuous life cycle of molecular gas clouds within Stephan's quintet. In a twist of events even more peculiar, scientists stumbled upon a vast accumulation of gas near the quintet, gradually dispersing as a distinct trail of heated gas emerged nearby. Simply put, this discovery suggests the presence of a young galaxy in the vicinity, adding another layer to the intriguing phenomena occurring in this distant region of the universe, fortunately located between 39 million and 340 million light-years away from your current position. Interestingly, one of the galaxies in Stephan's quintet is significantly closer than its companions in the forefront. Shockwaves, like the one impacting Stephan's quintet, typically occur when an object traverses through a gaseous region faster than the speed of sound. In this instance, NGC 731b is hurtling through space at an astonishing speed of 800 kilometers per second, or nearly 500 million meters per second. According to the press release, you could cover the distance from Earth to the Moon in just 8 minutes at such a velocity. Back in 2006, utilizing Spitzer, Caltech's astronomy team made a fascinating discovery. They observed a plethora of specific hydrogen molecules emitting infrared light within the shock wave, alongside X-ray emissions that would typically remain unaffected during such occurrences. Caltech explained that these molecules typically wouldn't survive shock waves exceeding speeds of 30 to 50 kilometers per second. Consequently, the team was intrigued by this anomaly, which circles us back to the intricate chaos mentioned earlier. As they elucidated, the space traversed by this shock wave exhibits irregularities, with these irregularities fragmenting into smaller entities known as cloudlets as the shock wave progresses. These cloudlets are the source of the mysterious hydrogen glow and eventually become integrated into the shock wave itself. In simpler terms, it appears that hydrogen in the vicinity is being recycled within both warm and cold gas surrounding the shock wave. In 2006, while observing the wave, the team discovered this regenerated hydrogen. According to them, this finding holds significance because molecular hydrogen serves as the fundamental building block that could eventually give rise to stars. Thus, understanding its fate provides further insights into the evolution of Stephan's quintet and galaxies at large. Furthermore, as a result of this recycling process, all this heightened activity leads to what we term as unforeseen formations. As the shock wave encounters its uneven obstacles, a stream of heated molecular hydrogen gas connects two frigid clouds, creating one of these peculiar shapes. Imagine a swift projectile slicing through a cloud and leaving behind a ring-shaped trail. The other structure resembles the tail of a nascent galaxy. What we're witnessing is the dissolution of a massive cloud of cold molecules into superheated gas. Intriguingly, it undergoes cycles of warmth and coolness. While we're still grappling with the intricacies of these cycles, we can infer that the gas is undergoing recycling because the trail persists longer than it takes for the clouds from which it originated to dissipate. Looking ahead, scientists' forthcoming plans involve employing spectroscopic analyses to meticulously track the movement of all the gas enveloping the shock wave. Through this endeavor, they aim to ascertain the velocity at which the gas is traveling and how it undergoes heating or cooling as the shock wave traverses the region. These recent discoveries have provided us with fresh insights, but they've also revealed that there's a wealth of unexplored territory awaiting discovery. Essentially, we've only just scratched the surface of this narrative. It's time to delve deeper and uncover more. On a forward-looking note, if Elon Musk were to have control over the James Webb Space Telescope, he expressed his intention to point it at a random spot in the universe. This way, the telescope, which is revolutionizing our understanding of space, could uncover phenomena and address questions that we haven't even conceived yet, without being constrained by our preconceived notions. However, do you believe Musk will ever realize his dream of venturing into outer space? Share your thoughts in the comments below, and don't forget to leave a like for more content.